Hello and welcome to this video. Today we're going to look at protons, neutrons, electrons, and atomic mass. And this is pretty much the basic, or the most basic idea in chemistry. An atom is made up of protons, neutrons, and electrons, and all of that comprises its atomic mass. You will be asked to determine what an atom's atomic mass is, given its number of protons and neutrons. You'll be asked to determine the number of protons, given the number of neutrons and atomic mass. But the guiding formula for this is your number of protons plus your number of neutrons is going to equal your atomic mass. And I'm going to show you on this example what everything means. So your number of protons, this right here, corresponds with or is always the your atomic number. So atomic number is the number of protons. Your atomic mass is this number down here. It'll always be the bigger number. So protons have a measurable mass. Neutrons have a measurable mass, and the mass of electrons, it has mass, it exists, it has mass, is very small compared to the proton mass and neutron mass. So the worksheet asks for you to list out the number of protons, neutrons, and electrons. So you could make an algebra problem out of this. So our atomic mass is 75 equals number of protons we have, which is our atomic number, which is 33, plus the number of neutrons, and I'm just going to write the letter N there. So we can do this. We can subtract 33 from both sides, and we get 2 and 4. So N equals 42. We can always check our math. We do 42 plus 33, and we get 75. So the number of protons we have is 33. I'll write this in a different color. The number of neutrons we have is 42. But that doesn't tell us how many electrons we have. Your electrons will generally be equal to the number of protons you have, okay? So on the periodic table, they're listed without a charge. Protons, it said they have a positive charge, so positive P. Electrons, we'll get to that, how we remember that in just a second. But neutrons have no charge, so they're neutral, and by the process of elimination, you know what electrons are. So electrons are negative. Working with these, none of these are ions. Ions are atoms that have charges. So it's either positively charged or negatively charged. For all of these, our protons are going to equal our electrons. because there's no charge. And if something had a charge, it would be written like this. So say this is arsenic. So say our arsenic had a charge, it would either be written as arsenic minus arsenic plus. And you may see some of these with different numbers there. So just for example, it could be arsenic minus 2 or arsenic plus 2. Generally, you won't see any number over 3, but chemistry can get kind of out there beyond what I will be able to teach you. So we said our protons equals our electrons. Our protons was 33, so our electrons are 33. Here are the answers. The rest of these I will explain less things. I'll just remember that our protons plus our neutrons equals our atomic mass, and that for this, protons equal electrons. So, moving on to number 2, bismuth. Bismuth is a pretty interesting metal. If you've ever heard of Pepto-Bismol, it's in there. It's used to replace lead in some things. Because lead is a heavy metal, it can really cause some medical problems. Arsenic can also cause medical problems too. But bismuth is in Pepto-Bismol, or the pink medicine for your stomach. So we have protons plus our neutrons equals our atomic mass, and protons equal electrons. So our protons for bismuth, we just look right here to our atomic number, it's 83. Our electrons, we'll go ahead and do that because it's just writing the number 83 again. And our neutrons. So let's write out our problem. It's 209. That's where I got that. That's the atomic mass. Equals neutrons plus 83. So 209 minus 83 minus 3, 6. So our neutrons are 126. Double check my work. So we'll add these two numbers together and make sure we get that number. So 6 plus 3 is 9. 8 plus 2 is 10. There we go. This is our answer right here. Calcium. Calcium is in a lot of stuff. It's in our bones, in our teeth. It's all over the place. And it's very, very important to the body. Also really important to a bunch of other stuff that makes life possible. So, writing out our equation again. Protons plus neutrons equals atomic mass. And protons equal electrons. So, our protons equal 20. Our electrons equal 20. And our neutrons equal, will be 40 equals, 40 is our atomic mass, equals our number of protons, which is 20, plus the number of neutrons. We subtract 20 from both sides, and we get 20 equals neutrons. So the number of neutrons we have is 20. And a lot of the smaller elements will, unless they have a charge, everything will just kind of be equal. So carbon, its atomic number is 6, its atomic mass is 12, and the number of electrons it has is 6. So everything is 6 in that example. But moving on to magnesium, we can see it's a fairly small element as well. So we have our protons, which equals 12. Our electrons equal 12. And our atomic mass is 24, equals 12 plus our neutrons. We get 12 equals the number of neutrons we have. So, alright. And the last one on this is oxygen. Oxygen, also pretty small. We have our protons, our neutrons, and our electrons here. Protons right there. Number 8. Neutrons is 16 equals 8 plus neutrons. 8 equals our neutrons. And this doesn't have any charge, so it is 8 here as well. Alright, they're working with examples where maybe we have like hydrogen anion, and we need to find out how many electrons that has, because if there's a charge, that affects the electrons. But thank you for watching, and if you wouldn't mind, like and subscribe. That helps me out, helps me keep making these videos. If you wouldn't mind, comment if you don't mind some you need help with, and I will produce some kind of assistance for that.